Dear listener, welcome to my channel. Main topic of this video is evaluation of information retrieval system. In this video, assessing relevance, Kappa Statistics, critics and justification of the concept of relevance, system quality, user utility, and refining a deployed system is covered in this video. Now let us start. Assessing relevance. Given information needs and documents, we need to collect relevance assessment. This is time consuming and expensive process involving the human beings. For large modern collection, relevance to be assessed only for subset of the documents, that is top K documents retrieved by different IR system for each query. The most standard approach is pooling. The top K results are merged into pool, duplicates are removed. Present the document in random order to analysis for relevance judgment. Now we will see with this example. For example, document collection, that is 1 lakh documents are there, and for that 1 lakh documents the queries which is to be fired on that data, they are 1000. 2 judges are there, 5 existing IR models are there which are retrieving the documents in a ranking order. For each query, this existing model retrieve the documents. Only the top 100 documents from each model are collected. Total results are 500 from each existing IR model, and here we make assumption that each model is retrieving that top 100 documents. After that, this approach is called pooling approach, that is we are collected the result. Now duplicates are there, they are removed. Duplicate is possible when same result is retrieved by 2 or more model. Let us assume that total 400 documents after filtration of duplicate results. These are presented to judges. They make a decision on document relevancy. Kappa measure is used to check consistency on judge decision. If Kappa measure is okay, then a relevant and non-relevant data set for top records is prepared for query 1. Same procedure is followed for the remaining queries. So in this way, relevance assessment is created for the queries for a given data set, and so that once that relevant and non-relevant data set is prepared for each query, for a new IR system we can easily utilize for the checking purpose. Kappa Statistics. Relevance assessment are only valuable if judges agree. Kappa is a tool that measures how much the judges agree or disagree. It's like scorecard for their consistency, and it is generally used for categorical judgments. High Kappa results, that is nothing but judges are agree for relevance or for non-relevance and making the assessment more trustworthy. Low Kappa means there is a problem and judges are giving inconsistent feedback, or they are not agree with each other on a particular document relevancy, and they making the results less reliable. Now we will see how Kappa measure is used. In Kappa measure, P of A and P of E is used. P of A is nothing but the probability, that is proportion of time judges agree, and P of E is nothing but what agreement would be get by chance. Values of K in the interval 2/3 to 1.0 are seen as acceptable as Kappa measure. With smaller values, need to redesign relevance assessment methodology. Formula is P of A minus P of E divided by 1 minus P of E. The Kappa value will be 1 when 2 judges always agree. If 0 if they are agree only at the rate given by chance, and negative if they are worse than the random. If there are more than 2 judges, it is normal to calculate an average pairwise Kappa value. That is, for example, 3 judges are there, we will calculate for 1 2 2 3 3 1, and after that we can take the average of the Kappa result. Now this is judge 1 relevance and judge 2 relevance, both are agree. Then there is a 4 combinations are possible. This is same as our confusion matrix. So this is TP, FP, FN and TN, but here this is instead of actual and predicted result, it is judge 1 and judge 2 relevance. Now this is represented by A, B, C and D. Here we require to make the addition of A plus B, C plus D, A plus C, B plus D, and total N is equal to A plus B plus C plus D. Now when that 2 judges are agree, that is nothing but P of A, which is nothing but A plus D by N. So this is A, both are agree and both don't agree, so that is the true cases. So A plus D by N, and probability now we require to take by chance. So probability of non-relevant. So for probability of non-relevant we are taking C plus D and B plus D divided by 2n. and for relevancy we are taking this a plus b and a plus c divided by 2n. Now for probability of chance we are taking the probability of relevant square plus probability of non-relevant square, and after that we will put the value into this formula and we will get the value of k. Example 1. Judge 1 and Judge 2 are there. For 300 documents, both are agree they are relevant. For 10, they are agree both are. For 70, they are agree both are non-relevant. For 20 and 10, one is relevant, second is non-relevant, and for fourth, that is 10 records, one is non-relevant and second is relevant. So we require to first make a confusion matrix in which Judge 1 relevance and Judge 2 relevance there, and we are writing the things. So R is relevant and NR is non-relevant. So we require to take this value and we require to fill this table. Now here first we will calculate the probability of A. So here we require to case that 300 plus 70 divided by total records are 400. So 400 comes, and we require to take the non-relevant. For non-relevant we require to take the negative result. So it is 80 plus 90 divided by 2 times, that is 800, and for relevancy we are taking this, that is 2 result, that is 320 plus 3110 divided by 800. So we make the calculation and we are getting the value. Now we require to calculate the P of E, which is equal to non-relevant square plus relevant square. So we are just simply squaring and the value is 0.67, and after that we are putting the value into the formula and we are getting the 0.776. So this is the kappa measure will vary between 0 to 1, and this is nothing but the interpretation of the kappa result. So up to 0 to 2 by 3, that is up to 75%, it should be acceptable. After that it is not acceptable. So from 0.66 to 1 it is acceptable. After that, before that it is not acceptable. So the result is 0.776. So we can say that it is substantial agreement is there. So the result is acceptable. Now we'll see the next example. Now sometimes they give directly table, so we require to make the judgment. So here for P of A, it is we require to take 45 plus 15 divided by 100, and it is 0.6. For non-relevant we require to take 40 plus 30 divided by 200, and for relevancy 60 plus 70 divided by 200. So we are getting the result for non-relevant 0.35 and probability of relevant 0.65 by chance. After that we will make the square and we will calculate the probability if that is by chance, and after that we are putting the value. So after this result we are getting the value 0.12. So slight agreement is there. So the result is not acceptable here, means both judges are not agree on the relevance or irrelevance conclusion. Now these 12 documents are given. 0 0 means both, that is it is nothing but the T of n case, that is both judge don't agree, that is both are relevant documents. 1 1 means that is again true case. So 0 0 is Tn and 1 1 is Tp, and 1 0 and 0 1 they are nothing but the cases of Fp and Fn. So in this way, from this table we require to first fill out this table. So just observe this table and try to fill the value in this table. So when 1 0 combination is there we are filling this, and when 0 1 combination is there we are filling this value, because for relevancy we are taking the value 1, sorry, for relevant we are taking the value 1, and for non-relevant we are taking the value 0. So in that way you require to identify. So 0 0 combination is this combination, 1 1 combination is this combination, then 1 0 combination is this combination, and 0 1 combination is this combination. So after that the calculation is very easy once you know the formula. So here sometimes we may get the kappa score as negative. So negative value indicates that there is very less agreement, so we should not accept the result. So that is the case. Now next portion is of theoretical, that is critics and justification of the concept of relevance. If we keep fixed judgment of relevant and irrelevant document for different query collection, then we can vary IR system and system parameters to carry out the comparative experiment. For example, when we perform that step 1, that is assessing relevance, we are getting the fixed number of, for a fixed number of query we are getting the fixed judgment of relevant and irrelevant, and that is justified by the judgment also. So once that system is ready, when we design a new IR system, we can run that IR system using that queries, and we can find out, or we can check our system whether it is working or not. And at the same time we can also change the system parameters to carry out the comparative experiments. Such a formal testing is much less expensive and allows clear diagnosis of the effect of changing the system parameters than doing the user studies of retrieval effectiveness. We can also proceed to optimize the effectiveness by machine learning methods rather than tuning the parameters by hand. So it may happen that instead of just changing the parameters and seeing the changes in the result, we can go for the new machine learning methods which will give the more accurate result to us. But here we are just thinking only of our side, that is the development side. So but formal measures poorly describe the users, what users actually want. They are not thinking from the user side, only from the implementation or development side. So doing this will not be effective in improving the user satisfaction. So here the concentration more is on the process from the developer side, but very less thinking on the user side. That is what users' final satisfaction is. Judgment by judges and marginal relevance. Judgment of relevance are subjective, varying across people. In practice, human assessors that we are using are also imperfect measuring instruments, susceptible to failure of understanding and attention. We also have to assume that user information need do not change as they are looking at the retrieval result. Any results based on the collection are heavily skewed by the choice of collection, queries and relevance judgment set. Some of the problem may be fixable. For example, a number of recent evaluation adopted an ordinal notion of relevance with documents divided into 3 classes instead of only 2 classes, relevant and non-relevant. Now classification level having 3 to 4 levels, distinguishing slightly relevant documents from highly relevant documents. So this change we can do, that instead of making only 2-way classification, we can go for multi-way classification. Marginal relevance. Whether a document still has distinctive usefulness after the user has looked at certain other documents. Even if a document is highly relevant, its information can be completely redundant with other documents which have already been examined, and this is very common on our World Wide Web. The most extreme case of this is that are duplicates, a phenomenon that is actually very common on the World Wide Web, but it can also easily occur when several documents provided a similar precise of the document. For example, on the net, when we give the query, we are getting the same information, only same information in the form of document, PPTs, videos, PDF format, but at last the material is same, that is content wise they are same, only the appearance is change. In such circumstances, the marginal relevance is clearly a better measure of utility to the user. Maximizing the marginal relevance requires returning documents that exhibit diversity and novelty. One way to approach measuring is this by using the distinct facts or entities as evaluation units, but this is very difficult to achieve. The perhaps more directly measure true utility to the user, but doing this makes it harder to create a test collection. A broader perspective, system quality and user utility. How satisfied is each user with the results the system gives for each information need that they pose? The standard way to measure human satisfaction is by using the various kinds of user studies. This might include quantitative and qualitative measures. Quantitative measures such as time to complete a task, user comments on search interface, and qualitative measure is nothing but the score for satisfaction with search engine. So we'll see in this detail. A broader perspective, the issues, system issues, user utility and refining a deployed system parts come. Now first we will see the system issues. How fast does it index? That is, how many documents per hour it index for a certain distribution or document lengths. This is measurable, and this is required if we want to satisfy the user in a very limited or fraction time. How fast does it search? That is, what is its latency as a function of index size, which is also measurable. How expressive is its query language? How fast is it on the complex queries? This is again qualitative, and it is very difficult, and even the today's search engine also are in the process of making the query language more expressive. How large it is in the document collection in terms of the number of documents or the collection having information distributed across the broad range of topics. This is again measurable. So these are nothing but the system issues. User utility. For web search engine, happy search users are those who find what they want. Other indirect measure of search user is that they tend to return to the same engine. Measuring the rate of the return of the users is thus an effective metric. If we could also measure how much these users used other search engine, then only we can make the true comparison. They are happy if the customers click to their sites and make the purchase. So this is given example for e-commerce website, but that is nothing but the user happiness, that is, it is returning to the website and it is doing some things like purchase. For example, on e-commerce website, a user is likely to be wanting to purchase something. Thus we can measure the time to purchase or the fraction of searchers who become buyers. On shopfront website, perhaps both the users and the store owners need to be satisfied if the purchase is made. We need to decide whether it is the users or e-commerce site owners happiness that we are trying to optimize, because the store owner is also paying to the search engine, so that is also the customer of search engine. Refining a deployed system. If an IR system has been built and being used by a large number of users, the system builder can evaluate possible changes by deploying variant version of the system and record the measures that are indicative of user satisfaction with one variant as with other that they are being used. This method is frequently used by web search engine, and this is a very famous, and it is used in the advertising industry. Example is A/B testing. For such a test, precisely one thing is changed between the current system and the proposed system, and small proportion of traffic is randomly directed to the variant system, while most users use the current system. So two versions of the systems are into the picture. New version is for the limited users and the old version is for the remaining user. For example, if we wish to investigate a change to the ranking algorithm, we redirect random sample of users to variant system and evaluate measures such as the frequency with which people click on the top result or any result on the first page. This particular analysis method is referred to as click-through log analysis or clickstring mining. It is one of the implicit feedback method, and the famous example or the use is A/B testing. The basis of A/B testing is running a bunch of single variable tests. For example, each test only one parameter is varied from the control. That is, we are using two systems, which one is the current and next is the proposed. It is therefore easy to say whether varying each parameter has positive or negative effect. Such testing of live system can easily and cheaply gauge the effect of change on users, and with large enough user base, it is practical to measure even very small positive and negative effect. More analytical power can be achieved by varying multiple things at once in uncorrelated way and doing the standard multivariate statistic analysis such as multiple linear regression. A/B testing is widely used because A/B tests are easy to deploy, easy to understand, and easy to explain the management. For example, if we are using one IR system for the document retrieval on the ranking, and it is using the vector model. After some time, if we develop a new model, so what we do, we will give a few users a different variant of the vector model, and the remaining users will use the basic vector model. After that, we will find out the change, that what happens with the normal vector model and what happens with the, or what users having feeling with the normal vector model and the modified vector model, and that is nothing but the A/B testing. So this is nothing but the all about the relevance assessment that is used for the evaluation of IR system. These are the references. Thank you.